1-1, okay, which is basically solving basic equations, okay? So, really quickly, most of this, like I said, should be reviewed. This whole unit, this whole class should be reviewed for you guys throughout your year. Now, does that necessarily mean that you should know everything? No, you guys might have forgot or whatever, and I understand that. So if you don't, I'm going to teach it like you don't. So, does that make sense? So better, faster, awesome. But if not, slow me down, talk to me. That's on you guys to understand what you need to do to be successful. Okay? Sometimes it's hard to say, I don't get that in front of a lot of people. I understand that. But I finally, it took me, my first year of college, where I was always nervous to do that, and finally I said, hey, I'm paying for this. I don't care what the hell they know. I need to know for me, right? And that's something that you got to get over. So just always be aware. Try to do stuff that's good for you. And if that means hold on, come in, whatever it might be, you need to come and voice your opinion for yourself, okay? All right, here we go. So, all right, it's very simple. Just starting out with linear equations, solving linear equations. All right, so 8x minus 10 equals 6. Our goal is to do what? Get x by himself. And how do we know that we're actually solving something? Because it's equal to something, right? It's not just an expression. This is an equation. An equation has an equal sign, okay? All right, so our first step is add the 10, okay? Basically, guys, when you think about things, okay, you do order of operations when we simplify things. Do you guys agree with that? Mm-hmm. Okay, you guys remember what order of operations are? Hey, you need me? Yeah. Yeah. I love a donut. You see this body? It's never refusing donuts. You like okay, so basically, guys, when we simplify things, we do order of operations. Remember, that's parentheses, exponent, multiplication or division. Do you guys know that it can be division or multiplication depending on what it is? Sometimes kids are always like, right? No, division or multiplication. Every time I'm on Facebook, I know you guys are on Facebook. Not cool. But they have like these little solving problems that they're like, what is the answer? I always love solving. I'm a math nerd, that's what happens. But a lot of people mess up because they'll have a division before a multiplication. And then they'll do the multiplication. Does that make sense? What else is after this? Addition and subtraction, whatever it is left to right on those as well. Okay, but when we solve, what do? We go backwards when we're solving. We do this stuff all the way backwards, right? So we get rid of the subtraction first. Then we get rid of the multiplication. Does that make sense to everybody? Okay, once again, I'm going to just write this down a little bit. 8x minus 10, was it? Okay, so what do we got? We're going to add 10 because we want to get rid of it. When we see an equal sign, what do we assume that to be? I think of a teeter-totter. Okay? You got two big kids on the same side. Now, if 10 pounds is being, if we're going to add 10 pounds to this side, what happens to my teeter-totter? Ooh, heavier on this side, right? What do we got to do this side to equal us back out? Add the 10 pounds. Okay? The equal sign is the teeter-totter. Okay? So be aware of that. Once again, a lot of you guys are like, Mr. Roberts, this is easy. I understand that. But once again, I'm teaching you guys, you've never seen this before. Okay? What do we got here? How do we get rid of a division? Oh, damn. How do we get rid of multiplication? Divide. Okay? Or we can always times by its reciprocal. Right? I don't mind dividing. X equals 2. Right? But another way is, once again, dividing is the same thing as timesing by a reciprocal. You guys know what a reciprocal is? So what's a reciprocal of 8? 1/8. -8 would be its opposite. Okay? I remember I used to get those two words mixed up. So opposite would be a -8. A reciprocal is just take the fraction and flip it. Okay? So I could also times by an 8. Hence the x equals 16/8, which is, okay? Any questions there? You feel good? Anything like that was horrible? Okay. Once again, please talk to me. More welcome. All right, here we go. This one's a little bit more intense. Not too bad though. Okay, hurry and write that down. Okay, what's different on this problem than the previous problem? We have two variables, don't we? Right? They're the same variable, but they're on different sides. So A, we want them on the same side. Does it matter what side we get them on? No, doesn't matter. Now, what I like to do, me personally, I always like to get it to the side that after I add it over, or get them on the same side, is trying to be positive. Does that make sense? So which way would be positive? Adding the 3 over to the other side, or adding the 5 over to the other side? I would add the 5 to both sides, so the fact at the end, it'll give me a positive z value. Make sense? Does it have to be that way? No. Okay, so I'm going to add 5z. Add 5z. Okay? Left over here is a 3 equals 2z plus 1. Now, guys, I'm going to assign you some homework. I want to kind of give you out this idea. And there's lots more problems on there than just the ones I'm doing. One thing that took me until I reached college, really, to be honest, is understanding that homework is a minimum thing I have to do. Does that make sense? What I assign you is a minimum thing. Now, if you do pretty well with that, with the homework I assign, then that means, hey, I feel pretty good. But if you're still struggling, then there's other options around that that you can do for extra practice. Correct? Yes? Feel good with that? Sometimes that took me a little bit to get in that mindset to say, hey, I might have to do other problems to make sure I'm successful. Okay? All right. Now, what is our goal now? I'm going to call on some people. How many striped pants right there? Help me your name. Paige, what are we going to do? Good, because once again, we want to get the variable by himself, right? So I'm going to subtract the 1. Okay? Decatur, what do you think we're going to do now, brother? Divide by 2. Okay? And after that, we're done, aren't we? And z equals what? Now, what's a nice thing that I love about math is I can make sure I am always right. Right? A lot of times I can check my work. So once again, what was my original equation so I don't have to look back up there? It was -5 z plus 3. All right, everybody agree with that? Now, I am going to insert my answer into the z's, because that's what it is z equals that, so I can substitute for that solution, can't I? Okay, so I have -5 times 1 plus 3 equals -3 times 1 plus 2. Oh, what the hell? 1. Okay. So notice I have -5 plus 3, which is -2. I have -3 plus 1 is, does it check? Okay. So obviously I can go ahead and check my work to make sure that. Do I have to do that? No. Just a way to make sure that I'm good to go. Okay? Any questions? Okay, now let's see if you guys can remember this one. This is example 3 off of this. I'm going to push pause. I'm going to let you guys try this one on your own. You guys read that X plus 1? Okay, I'm going to push pause. Okay, so the first thing that we're going to do is order of operations, right? We need to make sure that we have inside the parentheses nothing I can do within this. But this does say 10 times that amount, doesn't it? This says 4 times that amount. So what do we do there? We're going to, the word is distribute it through. So I have 10x minus 10. A lot of people do it to the front, but they forget to do it to the back. Remember to do it to both. Okay? Minus 4x equals 2x plus 1 plus 4x plus 4. Hippy hop hop hip. Okay. Now, notice I have multiple x's on the left side, multiple x's on the right side. So what I want to first do is combine like terms, right? Now, sometimes understanding it's just saying this is how many of those that I have, right? So I have 10 x's minus 4 x's. So how many we got? 6x minus 10 on this side. Notice 2x and 4x gives me 6x on this side. 1 plus 4 gives me 5 on this side. Are we good to there? Any questions going through it? Once again, please talk to me if so. Okay, this is something that's a little bit interesting. Okay, this is where somebody probably got stuck in hence why I kept going. I need to get them on the same side, don't I? Okay, so if I subtract the 6x, okay, they're gone. What kind of solution is this? This is a no solution, meaning no matter what I put in for x, they'll never equal each other. There's nothing else that equals y. You guys recall the word parallel. Parallel means, once again, that they have the same slope but different y-intercepts. So if things have the same slope, they're both rising and running the same amount, will they ever intersect? Because if we think about this as a line, this is basically down here. Here's -10. And then this one's at 6x plus 5. Oh, get out of there. So notice there's never going to be an intersection. Very good with that? Okay. So this is a no solution. Okay, does that make sense? Why it's a no solution though? Okay. Because no time when I put it, let's say I put x is 2, that's 12. 12 minus 10 is 2. That's 12 plus 5, does 2 equal 17? There's not a time that it'll ever work. Okay, go on. Is my handwriting get better? I've uh-huh. Go ahead, say again.
Oh, sorry, I was just asking, what is the line above the F again?
Oh, that's a 5.
Oh, a 5? Alright,
Love my life. That's a 5.
Okay.
So let's just read it just to make sure. R over 2 plus 2 times R plus 2 equals 5 over 2R plus 4. Okay, awesome. Once again, it takes a month. You'll get it.
Alright, I'll just remember lines above F.
There you go. Okay. Now, how many of you guys are like, oh, bubbled up these sticker links? I got a fraction. Let's raise your hand. Let's be honest. Okay. Okay. Let's do something first. I'm going to show you an easy way to get rid of fractions when you have an equal sign, okay? Because I don't even like to mess with fractions. Can I do them? Yes. Are fractions really hard? No. Are they tedious? Yes. Rules of fractions. Let's hurry and just go over them really quick. When I see fractions and I need to add or subtract fractions, what do I have to have? Common denominator. Think of Arnold Schwarzenegger, people. He's a common denominator. Right? The common denominator. 2. When I multiply fractions, what do I have to do? Straight across. Okay? 3. When I divide fractions, what do I do? Do I ever divide a fraction? Nope. I times by its reciprocal. You guys want to write those down? I'll hurry and write them one more time. A. If I'm adding or subtracting, I need a common denominator. Okay? If I am multiplying, multiply straight across. When I'm dividing, I multiply by reciprocal. Okay? Just remember those rules because fractions aren't going away. Okay? I understand all you guys freak out. I was in a math for elementary teacher class when I was in high school, not high school, college. And I swear half the elementary teachers are scared of fractions. They're really simple. Okay, here we go. First thing I'm going to do, guys, is I'm going to deal with this. Okay? I'm going to go with this fella. So what do we get? We get R over 2 still. Plus 2R plus 4. Remember to distribute through, right? Equals 5 over 2R plus 4. Okay. So, with this being said, ladies and gentlemen, we're at a lovely fraction. You're like, frick or frack or frick, aren't you? You don't really want to deal with it. Can somebody tell me a number that I can multiply to both sides to get rid of it? If I multiply both sides by 2, okay, watch what's going to happen. Now, understand, when I go ahead and do this, I'm distributing it to everything in here, right? Does that make sense? Because I'm doing parentheses, multiply this side by 2 and this side by 2. So, what's 2 times R over 2? 1. Isn't 2 over 2 just 1? So this is just R. You feel more comfortable now? Should be, right? What's 2 times 2R? 4R. 2 times 4? 8. Equals 2 times 5 halves R. 2 and the 2 would cancel, wouldn't they? Just be 5R. Plus 8R. Right? Okay. Combine like terms on the left side. You good back there, bud? Get pissed at yourself a little bit? It's okay. I get mad at myself. I'm like, what the heck did you just divide by a negative and forget the other side? You know what I mean? I feel your pain, people. Okay, what do we get? What do we get? What do we get? Get! I'm a morning person. You better wake up early, people. That's how I am all the damn time. Morning. Love it. So I get 8 equals 8, or you, as you said, I could get 0 equals 0, which means what? Not a no solution. It's an infinite solution. And the reason why they're infinite is because they're the exact same equation. Meaning, I can plug in whatever x value I need, it will equal the other side because. So, notice the last example was two numbers equaling that weren't the same, right? That was a no solution. Two numbers that equal each other with no variable is an infinite solution. Okay. How do we feel in this section? Can we move on to 1, 2? Okay, really quickly, I'm just going to hurry and show you this. We can just talk about it, but I don't want to solve it if that's okay. Okay, really quick, we're just going to talk about it. Oops, I don't know why I did that. I guess we could hurry and go through this. Oh, we see fractions again. Once again, easy way to do it when I have an equation, I just look for a number that can get rid of all three of those fractions. What number can get rid of a 9, a 2, and a 6? 18, right? Isn't that the least common multiple? Remember, where they all can multiply to be the same number. You guys agree with that? 18? Okay. So, once again, I just take this side. 18. Make some sound effects to help. When you're at home and you go like that, you all think you're weird, but I'll nap. Related. Okay. So here's how I do this process. Once again, I'm going to distribute it to this guy and to this guy, right? So the reason why we chose 18 is it gets rid of these fractions, doesn't it? What's 18 divided by 9? 2. So I'm going to say, okay, this is 2 parentheses 4x plus 3. You see what I did there? 18 divided by 9 is 2. Okay, now there's an 18 right here. 18 divided by 2 is what? 9. So I'll have a negative 9, parentheses, 2x plus 1. Okay, now what? On the other side, 18 divided by 6 is 3. 3 times 1 is 3. Okay. Did I just make that something that looked nasty into something that's really not? Right? Pretty easy. Any questions with that? You guys can go on from there, though. I don't need to keep going. Just wanted to show that step. Good, 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 good. Gingy, you all right? All right. Tell me your name again. I'm a half Gingy. See, my hair just goes red below this. So I call myself a Gingy. All right. Okay, 1-2, 1-2. By the way, for those people that are going to continue on into Math 1050, how many are signing up for Math 1050 as well? Yeah. I've been told that this part is harder than 1050, even though the topics are harder, just because we have to do so much with this class. Like we usually have 2 to 3 sections a day, whereas in the 1050 class we have 1. So just kind of understand, yes, it's a lot, but also at the same time, you should have seen this before somehow, correct? Is any of this stuff so far new to you guys? Okay, good. Awesome. All right, onward. Okay, 1-2 is using our words to go ahead and make an equation. Okay, so let's go over some words. What is a good word for the plus sign? What are some words that we use to say that? Addition, okay. Who said over here? Plus. Somebody else said something over there that I'm really looking for? Sum. That's a big one. Okay. The sum of two numbers is meaning you're adding two numbers together. Okay. Okay. How about a minus? What's another word? We've heard minus before, right? Difference is the big word we're looking for. Okay. Multiplication. Times, okay, that's a good one. Product is the big one. When I say a product of two numbers, that's times. Okay. How about divide? Starts with a Q. Quotient. Okay. An equal sign. What's the word usually we use for that? Equals is a possibility. Is. Is. Say again, I'm sorry. There you go. Could be a seesaw, but they're not going to say in your problem. The product of two numbers seesaw. You know what I mean? So you get what I'm saying. It is a seesaw. Like treat it like a seesaw or a teeter totter, right? But when we use the term, is would be what we're looking at. The product of two numbers is that. We can also use more than, okay, less than, more than or equal to, or greater than, or needs to be at least. All those words are things that we can use within equality. Right? All right. Any questions there? Yes, no, maybe so. Hooty hotty, pig. Okay, here we go. Oops, example 1 for this one. That's your difference. The difference of 10 and a number is 6. Anybody want to give a shot at it? Go ahead, back here, bud. Awesome. difference between those two numbers is, what is that number?
4.
Okay. Any questions there? Pretty explanatory. Do another one. Whoa, that's messed up. Okay, it says the sum of 2 times a number and 3 is 16. There's multiple things happening on this. You sad that your mom's not going to be here anymore? I'm a little sad. Yeah, really hurt my feelings. I was like, I'm done. I can scare your mom. It's fun. One of my goals every day. Okay, any questions? Any questions? Here we go. Anybody want to try it? Yes, tell me your name again. Jamie. Like Mike. Pretty sure. Go. There you go. Okay. Now I'm going to write one that's almost the same, but it's slightly different. So you guys write that down really quick. Okay, here we go. I'm going to look at it just to make sure I have it in the same way. Anybody know what time we got here? I suck at time. It is still 9:10. I probably switched. You ready? You ready? Huh? Yeah, it's different. Is it just a minute? We'll plan at 9:05. We'll be done around that. Twice the sum of y and 3 is 6. This one's slightly different than what's being asked on the previous one. What's the sum that we're looking for? Y plus 3, huh? Okay, so you're actually taking the sum of this first. Well, what does it say? Twice the sum. Okay? You see the difference? Last time it said 2 times a number. What did it say? The sum of 2 times a number. Now notice the difference here is it says the sum, then the things that we're adding together, right? This time it said we're doing twice, then the sum. Okay? Yes, no? Hooty, hotty, hooty, hi, hey? Yeah? You just give me some dirty looks every now and then. You're like, I don't want to be here. I don't know why you really want to say that when you see my face. Okay. Anyone else? Good? See what else we got. Where did I put it on? Okay, here we go. Okay. The sum of 4 consecutive numbers is 104. Find all 4 numbers. What does consecutive mean? In a row. So give me just an example of any 4 consecutive numbers. I don't care. What? That would not be 4 consecutive numbers. That'd be 4 consecutive evens. 1, 2, 3, 4, right? Okay. How would I find the sum of 1, 2, 3, 4? Just 1 plus 2 plus 3 plus 4, right? But do I know what these numbers are? Do I know what we start with? We don't start with 104. That means that they add to be 104. Right? So do we know what we're starting with? So we're going to call our very first number x. Okay. Well, what's our next number? X plus 1. Because if you think about it, 4 consecutive numbers. If I had 3, how do we get 3 to 4? We just add 1. Right? So that's our first number. Here's our second number. Correct? Because here's 3. How do I get 3 to 4? I just take 3, which is x, and add 1. How do I get 3 to 5? Or in our case, x plus 2. And notice, isn't the difference between 4 and 5 just a difference of 1? Hence why there's only a difference of 1. Right? Okay. Okay, once again, we had 3, 4, 5. What's our next number? 6. How does 3 get to 6? So it'd be plus x plus 3 equals the sum of our 4 consecutive numbers, 104. I know I went into the blue, but that's 104. Okay, Landon, right? Landon said 2, 4, 6, 8. What would you consider that? 4 consecutive even numbers. Okay, so how would I write that out just for curiosity? I'd start with 2, 4, 6, 8. I'd start out with x. How does 2 get to 4? So it'd be x plus 2, x plus 4, x plus 6. Does that make sense how you're going to do it? How about if I did consecutive odd? 1, 3, 5, 9, 7. Darn it. Ooh, that's close. 1, 3, 5, 7. X plus 2, x plus 4, x plus 6. Make sense? Okay. Awesome. Okay. Do I have to multiply anything into these binomials? The parentheses? So basically, I could really drop them if I wanted, right? Okay. So notice, how many x's do I have? I have 4 x's. Equal, and then I got 1, 3, 6. Does everybody understand how I have those together? 3 plus 2 is 5 plus 1 is 6. That's interesting. Can I read that right? Sorry, give me a second. Just want to make sure. All right, hold on. This doesn't work. Whatever. I was like looking at this problem, like, I read it wrong. It was actually 4 consecutive odd numbers was the problem. So does that change our answer? Is this one going to work? No. Watch. Let me hear you figure out, show you why, how I did it in my head. I'm like, oh, my fricker cracker, 98 can't go, 4 can't go into 98. Is that a number? It is a number, but it's not a whole number. So I did something wrong. Okay, what would I change if it was odd consecutive numbers? So this would be x plus 2, x plus 4, and x plus 6. Let's try and just change that really quick and see if we can do it the right way. I apologize for my wrongdoing to you and your family. I'll just rewrite it a little bit slower. Say again? That would still be odd. Let me explain why. Give me once again 4 consecutive odd numbers, any of them that you want. 1, 3, 5, 7, right? How does 1 get to 3? Have to add 2. Even, odd, and even are still. What are even and odd numbers? They're always 2 away from you. Right? Does that make sense to you? Okay, so I'm going to rewrite this equation just a little bit lower because it looks like 2. It was x plus 2, x plus 4, x plus 6. Is that better? You guys can see it? Okay. Once again, we still have 4 x's. 2 plus 4 is 6, plus 6 is 12. Now I feel better. You okay?
Yeah, I'm just trying to solve that.
There's my 4. 2 plus 4 plus 6 is 12. I can go into there 23 times. So that's my first odd number. What's my next odd number? 25, 27, 20. Which would be my 4 consecutive. Right? You guys know? Yes, ma'am. No, sorry.
Whenever you use
Well, it depends on what they're asking. If they're asking just to find the equation, just write it down. If they're asking you to solve or to what is the specific number for the solution, answer your question. Okay, do you guys know how sales tax works? Anybody know how sales tax works? We go to the grocery store. Let's say we have a 10% tax. Something costs $10. What's the price going to be as you go out the door? $11, right? Because how does tax work? You take that 10% of the amount that you bought, okay, and then add it back to the original amount, right? We don't get lower amount. The tax is just a percentage of our amount that we spent, correct? Okay, so just be aware of that. So you might just want to think about that. Let's say we go to the store and it's $62.50. Tax is 3%. Okay, that's how much I spend, but how much is my total? Okay, what's going to be my total? You see the difference? Because once again, we go in and see something, we see a price, but that's not what we pay. Right? So here's what I do. I say, okay, I take my $62.50 because that's no matter what I'm going to be paying that. But then I add that to how much my tax is going to be, which is, how do I write 3%? 0.03 times 62.50 would be my total, right? Oh, yep, thank you. So, thank you. Okay, can somebody help me out? 0.03 times 250. Is that the total answer? What about just somebody tell me just this? 0.03 times 62. Huh? Now, to be honest, guys, in the grocery store, what do they charge you there? We don't have a half a cent, do we? They would give us 88. What even if that was a 2? What would they do? They'd round it up. Do you guys know there was a guy that would go? He had like a system that he was taking tenths of a penny. from people's accounts. It took him, he became a millionaire because he was taking tenths of a penny. Nobody could really recognize it off of their account. Pretty cool. Anyway, not that cool. I mean, it's illegal, but don't do that. But you know what I'm saying? Sometimes we don't think of that even being worth it, you know? So 6250 plus, so we got this. 8, a 3, a 4, 64, 38 would be my total of my cost, right? How does averages work, ladies and gentlemen? Gotta find one of those suckers. Okay. So let's kind of think about what you guys are going to do on your test for this class. Let's say we have 5 tests, okay? And then the final. The final is basically worth 2 tests in 1. You guys see how that's reasonable? It's roughly, you do 5 tests, 60% of your grade is a test, right? Each test is roughly 12%. What was our final worth? So isn't our final worth 2 tests, basically? A little bit more, but basically, you guys with me on that? Okay, so let's say we went through the year. Here's what your first 5 tests were. You got a 78, a 92, a 63, an 84, and a 71. Okay? You're getting a little nervous. You're like, oh, somebody hurry quickly. Tell me what the average of that is. How would I find average? Add them all up and divide by 5. Okay, quickly find out the average for me. 77.6, right? I want a second on that. Okay, awesome. So we add that up, divide by 5, that's the average. Okay? So let's say I was a little nervous on my final. Okay? So I say to myself, okay, what do I have to get to make sure I get a 70% so I pass the test? Because a lot of times in college, a D is a passing grade, but it doesn't pass the good. So understand those. So like a C minus is really out of what you want to get in college class. Because usually they'll let you carry on and go on to the next class. Does that make sense? Anything with a D, yes, you pass the class, but they usually won't let you continue on. Okay? So, what score would I need on my final to make sure I at least get a 70%? Well, how many tests is this final way with life? 2 of them. So can I say, okay, test 6 is going to be X, test 7 is also going to be X. Right? Because those 2 test amounts are going to be the same. But they're basically treated like 2 tests. Does that make sense to everybody? Hey, what is the average that we're looking for? What do we want it to be? 7. We want this to be 7. How many tests are there? 7. And if I add this all up, sorry, I ran out of room. So think about this, what is this saying? What is this saying on this side? The average of my tests, isn't that what it's saying? Should be equal to 7. Okay, you guys see how I did that? Took the average of all 7 tests. Now, the final being worth 2 test scores, hence I did X, X. With me on that? Okay, and I just add those all up. So once again, you already added this up for me once. What was all this stuff right here? Landon, right? 388 was what this stuff was. Okay, so I have 388 plus 2x over 7 equals 7. How do I solve such an equation? Right? Multiply both sides by 7. So I'm going to get there really quick. So I'm multiplying both sides by 7. You cancel.
That's what the is.
And then divide by 2. My final, if I need to get a 70%, all I have to do is get a. And that makes sense, doesn't it? Because if my average coming into that test was 77.6, is that what it was?
Yeah.
If your average coming into that is a 77.6, you really have to bomb it to really decrease it a lot, doesn't it? So basically, you did bomb it with a 56. You ended up with 70% overall. Oh, damn. Yep. Love you even more. I made mistakes, guys. I appreciate you. Okay. Last thing we're going to do, we're going to do 2 examples in 1-3. It's very simple. That's the equation of a line, isn't it? We all know that? Okay. I want you to solve for m. I want to get m by himself. Okay? So basically, I need to solve just like I was doing in that first section I was doing in 1.1. Except I don't have numbers this time, I just have variables, which for some reason people get stressed about. Okay, you'll be okay. Here we go. Watch. I want to get him by himself. So how do I get rid of him? Subtract it. Correct? So who do I want by himself? M. And that says m times x. So I divide by x. There it is. Okay. All right. Let's say I'm over in Europe, or even Canada. Okay? Anybody knows what happens up in Canada in Europe? They say it's 33 degrees outside. We're like, it's so freaking hot. It can't be 33 degrees because they're in what? Celsius. So in your mind, you're like, what the heck is this in Fahrenheit? Because then we can kind of figure out what it is mentally to us, right? We got to kind of think about what it is. Here's the equation. Fahrenheit equals 9/5 of Celsius. Oops, that's a C. Plus 32. Okay? Well, that's us going to Europe. Most of the world uses what? Celsius, right? We're pretty much the only ones use Fahrenheit. Okay? So, let's say a European person came here. And we're saying it's 99 degrees outside. How are they going to figure it out in Celsius? Well, let's hurry and get a conversion for them so it's a little bit easier, just a formula. Okay? So, how do I solve for C? Subtract the 32. Once again, that says times. Do we want to divide by a fraction ever? We want to times by it reciprocal. So we're going to times by 5/9. So Celsius is so they would take 99, subtract 32, times it by 5. Okay? I want to hand out the homework papers first, and then if we have time, I'd like to do one more. but I just want to make sure that we are getting your homework out to get through that one at a time. If there's extras, pass them to your left. Here's going to get all those. Hopefully there's 2 more coming. I have no for her. Another one. Actually, Philip? Whoa. Come on. You're for the time waiting. Be a gentleman. Let me grab it. Wow! Almost killed you. Okay, gentlemen, right here, whoever needs them. Thanks, guys. Have a great day. Do the numbers on the top.
Okay, cool.
Yep.
Are we skipping the numbers or are we doing?
Just doing the numbers on top.